Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. No engine, no libraries, it's just us here. And right now we're kind of at a little bit of a wind down. We did a bunch of work to both make our renderer operate in SIMD and to make the renderer operate multi-threaded, which turned out to be actually incredibly beneficial because our renderer now runs 1920 by 1080 at 60 frames a second, which was so far and away above what I was planning on making sure we hit. I was thinking we would just try to maybe do a quarter of that at 30 frames a second. So we're 8 times faster right now than I was thinking our target would be, and I don't know what to make of that other than gosh, machines are fast, I guess is what I'd say. But we do have now a bunch of sort of cleanup work that we have to do because we kind of were like pushing through the renderer and doing explorations there to try and get things going, but now we kind of want to solidify the renderer into something that actually renders the game reliably in the way that we want it to. And so there's a couple things that have to happen for that. And we kind of want to go through and sort those out. So we're going to do that. That is what we're going to do now. And if you would like to join me as we do that at home, today is day 130, which means you can unpack day 129 source code. And you will, if you start with that, you will start exactly where I am right now. So let's go ahead and open things up here. Okay. And so where we left off yesterday, we had gotten to the point where we had these sort of splatty things happening, right? These little splat patterns that we were making our ground tiles in, and I noticed that we had some seams in them. And so what I wanted to do now that we've got the renderer kind of working the way that we expect it to and stuff, I would like to go in and investigate to see if we can figure out if there's anything in particular happening with these seams that should concern us. And there's a couple reasons why that's going to be a little bit of, it's going to take some work. For starters, we don't actually know where the seams are coming from. There could be tons of places where those seams are coming from. We could have a bug in our source art where it doesn't have completely smooth alpha, right? We could have a bug in our code that actually blitz these tiles to the screen such that they're not meeting up perfectly, which would mean that actually they would be seamless if they were blitted to a different location. We could have a problem with the way that we're doing our splats such that when we produce a ground tile, we're not correctly layering in the other splats from the other tiles. There's just a ton of places where that problem could be occurring, right? And so it's, like I said, very difficult for us to kind of start to think about what is actually going on there. So what I'd like to do is start doing some experiments so I can try to just to see kind of basically taking the thing and shaking it a little and seeing if we can hear anything rattle around inside so that I can see whether there is something in particular that I should be looking for or if I need to really just do a completely general walkthrough, right? And so the first thing that I'm going to do to try and take the source out of the equation is I would like to play around a little with what source art is actually being used so that we can see. And there's something that's kind of unusual, I would say, about the patterns that I'm seeing here, and I want to point it out to you just so you can kind of be on a similar page, right? And the thing that I find that's pretty unusual about what I'm seeing is when I look, and you can kind of see here, I wonder if we should maybe zoom in on this. In fact, I think maybe we should so that we can see it a little bit more carefully. Let me go ahead and make a little smaller version of our window here. So in the renderer now, we should be able to zoom in essentially for free, right? Because since we pass a focal length in when we do our perspective transform, right? We can, and in fact, I'll go ahead and put those here. We have a focal length, right? And we also have a distance above ground, right? So if we want to, we can go ahead and change that distance above ground, right? So, you know, here it is at 9 or whatever, but if we wanted to move closer, we could change it to 5, right? And so we have the ability to just kind of, now that our renderer actually works and does all kinds of fancy things, we can do stuff like that, and it's no big deal. And so, you know, zooming in on this and looking at it, right, I have to say that even just looking at it right now and kind of eyeballing it, I would say that it looks to me a lot like this. It looks to me a lot like this is just a little bit too low, right? It looks like it's, or I should say, or this is too high, right? It looks to me like if this were just moved down a little bit, you would not have this problem. I'm going to go ahead and zoom in even further, just so we can really see what's going on there. But I don't know if you can kind of see, I feel like this right here, if this were moved down and this line were to continue, right, that this would kind of be in the correct place a little bit lower. And so, you know, I don't really know for sure. I can't say for sure, but I'm just looking at it. It feels a little bit like that's the case to me. And so maybe that is the first thing that I will do to try and look for the problem, is see whether these things are lining up properly. And so in order to do that, the first thing that I'm going to try is when we actually render these ground tiles, I'm going to see what happens if I start moving them, separating them a little bit further from where they should be, according to what would line up. And when I do that, I want to see, what I'm looking for is I want to see whether I see a crack between them or not. Because I should see a crack form between them when I separate them, but if they continue to sort of separate and draw into the gap, then I know that the way that I'm drawing them, they're actually being drawn too close together and they're overlapping each other, which is not, I want them to abut, right? And so that would, you know, just that alone would definitely cause a seam. So let's go ahead and look at where we're calling that, right? So here's our ground chunk rendering. And when we do the ground chunk rendering, we're pushing it on here. And we're calling ground side in meters, which looks like exactly what we would have expected it to be. So that seems pretty good when we do the push bitmap call. So it feels like it should be roughly the right thing. In fact, you know what I could do that's even easier than that? What I could do is start to multiply this by a value to shrink them down, right? So let me go ahead and multiply that by something to shrink them down. Okay. So now what I'm going to do is I'm going to back them up until they just exactly touch, and then I'm going to see, you know, is that number actually the right, is that actually at 1.0, or is it a little bit past 1.0, right? If that makes sense. All right. So at 9999, there they go. They've joined, right? So it looks like we're drawing them at the right size, right? There's no, they are exactly abutting. There doesn't appear to be anything funky going on with that, right? As far as I can tell, that looks totally fine. So I don't think we have any problem with our pixel fill here, although there is one thing that we don't quite do yet with our pixel fill that we probably do need to do to be absolutely perfect. But in terms of visible artifacts, I don't think that's actually causing any. You can see this guy, this splat right here, for example, also has that seam. And again, if I change it so that we just separate them even a baby bit, you can see that there's nothing there. So it's not a case of that, right? So now the next thing that we have to think about, right? And I'm hoping that this has something to do with it, because we kind of need to go address this in general anyway. And that is that you remember inside the renderer, we did not actually figure out what we were going to do with the tiling in here. And so this is kind of, and in fact, now that I think about it, there's a couple things that we have to talk about here. And in fact, one of them would cause a seam. One of them will definitely cause a seam. So now that I think about it, we would have had a seam from this even if we didn't have a seam from anything else. So this is kind of interesting. And we'll have to talk about that in a second. But if you remember here, right, we had this formalized texture boundaries thing, and we never really did that. And so, you know, if you think about what happens here, If we're not exactly sampling the textures 100% properly, then obviously we're going to have a problem with that, and we need to figure out what we're going to do to address that, because the bilinear, implies a lot of stuff here. So let me go to the blackboard and explain what I was just realizing there, because I feel like it's going to be crucial to us getting us into a state where it is perfectly seam free. So there's day 130. And what I want to talk about here is I want to talk about bilinear filtering and the implications it has for rendering things in tiles. Okay. So here's what we currently have, right? We currently have some tiles, and let's say for the sake of argument, right, that these tiles don't have a lot of pixels in them. Now, we made our tiles much bigger than this. Our tiles are something like 256 by 256, but let's say they were actually just 6 by 6, which is what I happen to draw here, right? And so right up abutting next to this guy, right, is going to be another, right, there's another dude in here. Okay? And so here's one ground chunk, and here's the next ground chunk. Now there's a couple things, if I want these to actually be, when we draw them on the screen, if I want these to actually be correct, there's a couple things that have to be true. The first thing is that I have to properly draw to all the pixels, which we just checked. And the second thing is that the color values that are chosen for the pixels that happen to be like right around here have to line up exactly at the edge with the same colors that would be chosen here. So like the pixels chosen here have to be the exact, they have to be exactly on the function, right? If the color values, if let's say this was grayscale or something, right? And the color value curve kind of looked like this, we have to make sure that we're like producing pixels that are right along the color values, right? And that there isn't some discontinuous step that would be perceptible at this boundary, right? The example would be, suppose, if you think of this more as a function or something like this, that you could visualize a little bit more easily in 1D, suppose that I were to draw a sine wave of grayscale values, right, in there. So, actually I guess it would look more like this, right? So if we were to have white here and black down here, if I were to draw this in and we were to take samples at these, we were drawing these in here or whatever, we would want to make sure that as we redrew this onto the screen, that we didn't have some discontinuous jump across this boundary that was different from the jump it was here, right? So when it's filling pixels and it's going like, oh, okay, I was here and then I was here, right? If the next one is over here, you're going to see that is wrong, right? Or if it's like right here or something, you're going to see that's wrong because the person's expecting it to look like it was at a different place, right? Because they'll see that discontinuity. It's a little hard to understand, I guess, but when you're talking about looking at something like a seam, you can imagine things a little more dramatic, right? If a line was passing through these pixels like this, you couldn't then have the line kind of pass through like that over here, right? Because you'd see that little jump, no matter how tiny it is, unless it was essentially well below a pixel, you'd have that problem, right? And so the reason that I bring all this up is because we actually have a problem here that we are not addressing, right? The problem is that we have a function that we're actually using to reconstruct smooth colors from a bitmap, right? It's our bilinear filtering function, right? So our whole thing does this bilinear filter function where it blends, whenever you ask for like a color here, it blends between these four colors to produce what the color is, right? And so think about what that does on the edge here, okay? What that needs to do on the edge here is as you start drawing out to this edge actually needs to produce the halfway point between this pixel and this pixel. But the problem is this pixel exists in a different bitmap, right? Because this is tile B and this is tile A. So how is the renderer ever going to know what color to produce out here, right? It can't possibly know. Hopefully you can see why that's a little bit of a problem, right? So we have a pretty significant problem that we would have to resolve there. We have to find a way that we can fix this problem. We have to find a way that we can do our sampling in a way that doesn't have this issue. And so what I think I might propose, because I can't think of a lot of reasons not to do it. What I might propose for this game is that instead of our texture mapping being based on texture mapping an entire rectangle like this, what I'm thinking is, what if we were to base it on texture mapping a rectangle that had 1 pixel's worth of stuff around it, right? So what we would actually do is we'd actually have, this. Here is, so instead of, if we had a 6 pixel bitmap, we would actually interpret it, right, as 4 pixels by 4 pixels with a 1 pixel border all the way around it. Okay? Does that make sense? And so this 1 pixel border everywhere around it stores what the color would be in the adjoining thing, so that when we then draw another one next to it, right, we just make sure that it has in that border pixel a copy of what the other person's pixel would have been, so that the function is reconstructed properly. Hopefully that makes some sense. So that's what I would propose. This also works out kind of nicely, actually, now that I think about it. The reason it works out kind of nicely is in order to get proper anti-aliasing for our sprites, we want a 1 pixel border around all of them that is filled with nothing, so that it always bilinears out to 0, so that way we're always fetching into the texture and we don't have any hard borders. So I feel like, that's probably something that we would want anyway. I'm just thinking, I'm not 100% positive, but I think that's probably something we want anyway. So I feel like what we'll probably do is we'll just go with this. So that's something we definitely have to fix. So since it's something we definitely have to fix, I'm just going to go ahead and fix it. So yeah. So first thing I'm going to do to fix that is think about how we're doing our UVs here, right? What I want to do is make it so our UVs are at that first pixel when they're at 0, 0, right? And so what that means is that when we actually sample into a texture, when we have our 0, 0, it's actually not going to be at the bottom corner. Draw a rectangle quickly. Okay. So let's go in here and take a look at that, right? So here we go. In here, here's our textile fetch, right? You can see our fetching. And when we do the fetching, we're doing it off of our fetch x, fetch y, right? And so what we want to do here is we want to do, in fact, our width m2 and our height m2, I think is actually kind of correct. That's actually getting pretty close to correct, but let's just finish. So what we want to do here is say, okay, well, yeah. So what we want to say is the 0, 0 coordinate of this would be like right here. So this would be the 0, 0 texture coordinate, right? And this is like a this is a value that no one would ever be allowed to actually sample from. It's strictly there because we will be sampling kind of back from it or whatever. So the 0, 0 value is actually going to sample, starting from this guy. Now I got to think about this a little bit. Let's think about this a little carefully here, because we also have another thing which we need to think about, which is the pixels themselves, right? So let's suppose we're blitting this and we're blitting it, to an actual place where it's completely aligned. So we're doing this, and we want to draw, from here. So if we were to pass in a fill like so, right? This would be whatever this pixel coordinate is, right? And this would be whatever this pixel coordinate is at the center. So let's say that we're talking about the center of a pixel, right? And so if something's 1, 2, 3 wide, it would be that big, and if it's 4 wide, right, it would be out to here. Right? 1, 2, 3, 4, like so. So I have to think about that. 1, 2, 3, 4. Yes. So if we assume that we're using, again, that sort of, if we assume that we're using that fill rule, where we're basically saying if your maximum is less than the pixel, then you wouldn't fill it, right? So something that's 4 wide would just barely not fill this guy. So I think that's a pretty traditional way of doing pixel centers. I am not Mr. Pixel Centers, so someone who's a graphics expert can correct me if I'm wrong. But so if we were to draw to that pixel, then drawing to that pixel, I guess what I'm saying is we'd want that to map to here, right? And then when we specify this guy here, right, I would guess it would map to there, right? So let me see what that actually gives us. So if this is A, right, then we're sampling right in the middle of A, which is what I think we would want to do. Again, we have to kind of back this out into the actual calculation in a minute, but we would want to sample right in the middle of A. Here we would want to sample right in the middle of B, C, and D, and that's good. And this would actually start to sample the in-between of these two as it goes that way, right? So I think that is correct, because that is what would guarantee us the ability to do both blitz. So what you can see here is there's like a 0.5 offset between these two things in some sense, right? Meaning that we want to sample right in the middle of A, which in the middle of A is actually, this is actually 0, 0 in the bitmap sense, right? So if our texture coordinates are 0, 0 here, that's actually negative 0.5, negative 0.5 in texels, right? Because the texel lookup has to use integers, if that makes sense. So we want the integer 0, 0 to line up right here, essentially. So I think that's roughly correct with the pixel centers. So I'm going to try to make that work that way. And I believe we're already doing pixel centers this way, if I'm not mistaken, meaning that the pixel's coordinate is right at its center. That's already sort of the way we were conceptualizing it. But yeah, I guess I haven't been 100% thorough on that. We do need to do something for our fill rule. Right now, I think we would fill these pixels, and we probably don't want to do that, but that's a separate issue. Anyway, although I guess the alpha there would be 0. Anyway, doesn't matter. Point being, so if we're going to do this, we first need to figure out how to adjust these texture coordinates, right? And so at A, what we want to produce if we were in this scenario, right? The reason I say that we want to bias it is because, remember, we're going to do a bilinear blend, right? So we have memory, right? We've got our memory out here that actually has the texture things in it. A, B, C, D, E, F, right? And if we fetch from 0, 0, we're going to get A, right? And if we fetch from, 0.5, 0.5, we're still going to get A, right? But we're going to grab some of B, F, and E, right? We're going to go halfway to them, right? And that's not what we actually wanted. What we actually want now is we want 0, 0 to sort of to map to an in-between. We want 0, 0 to be the in-between of whatever these negative pixels are, these border pixels, and A, right? That's what 0, 0 should be. It should actually be a blend. And 0.5, 0.5 of a texel, which, again, we don't know if this is a 4x4, then what's 0.5 of that? It's going to be 0.0, so 0.5 of a texel in UV coordinates is going to be 0.5 divided by 4, right? So 0.1 something, if that makes sense. So in UV coordinates, right, we need to do that. We need to do that bias, right? We need to bias it by that half texel. that's just something we have to do. Okay. So let's take a look at how we might do that. It's kind of fun to have this guy so giant. He's huge. All right. So what I want to do here is I want to say, okay, first of all, we'll deal with the scaling a little bit later. We'll talk about the scaling a little bit later. But what we want to do here before we do our fetch, right, when we compute the UV coordinates, we want to be able to bias the UV coordinates in texel space in order to get them into this correct position here, right? So we want to bias them in texture space. We want to bias them, I think, by negative 0.5, right, from where they were. But we also want to account for the phantom row of pixels that's going to be there, right, that we're not mapping. So we really want to add 0.5, because, you know, we're starting here and we want to bias by 0.5. So we want to basically say, like, we want to bias by 1 and then subtract 0.5, right, of a texel. So after we've already multiplied by the width to put us into texel space, I think that's what we want to do, right? Now, I don't know if we actually have that value loaded. It seems like a value that we might keep loaded. Let's see here for, you know, for other reasons, but I don't actually remember. It doesn't look like we have a half here. I do not see it. So I'm going to go ahead and introduce one. I'm just going to introduce a half, right? And that's just 0.5. And so what I want to do now, when we compute our fetch coordinates again, I want to go ahead and compute those. I want to go ahead and compute those with a bias. And so in here, we'd basically have an add PS, right? And I'm going to bias them, right? See here, like so. So this is, see, bias texture coordinates by plus, or by minus 1 texels plus 0.5 texels, right? To produce the proper alignment for sampling. All right. So if we assume that we do that, right, and so we assume that we're going to step it properly so that that is aligned there, then the other question I have is how far we want it to actually go. And again, I think we're actually doing that properly already by saying the width minus 2, because whatever the width of this texture actually is, right, we want to take out 2 of the pixels, basically, right? We want to not count 2 rows and 2 columns, right? So I think width minus 2 is actually the proper thing that we would want to have happen there. Yeah, so that seems reasonable. I've done, no. I did that wrong. I'm sorry. I take it back. I take it back. We are trying to put ourselves into pixel space. So this is not, it's the other way around, right? So we are here, right? And we have this phantom row of pixels. So we want 0, 0 to map to 1, 1, right? Right, minus 0.5, 0.5. So it's actually just adding, maybe I did do it correctly. I've confused my own self. Let me say it one more time. So this is the way it goes sometimes. So here's our phantom pixel in the texture map. We want 0, 0 to map to here, right? Which is in pixel in texels, in the bitmap, it's 0.5, 0.5. So I feel like I just, I guess I did it sort of properly by accident. Bias the texture coordinates to start on the boundary between the 0th and 1st pixels. I guess let's say the 0, 0, and 1, 1 pixel, right? And I think that is what does that, right? Yeah. I think that is what does that. So that seems right to me. All right, I wrote the right code, or well, it's probably very premature to say that it's right. I wrote some code, and it was, you know, not what I expected it to be. All right, anyway, so all that did was introduce that little bit of bias there, and so that shouldn't really change anything all that much. But now we at least have that phantom set of pixels, and that again, we can sort of try to debug later with little structured art to make sure that it's actually working. And then in terms of how big this actually is, like I said before, I feel like it's still correct in terms of the width minus and height minus 2. So I think that was actually right. So that's my assumption. Can't say for sure whether it's correct, but I think that's basically what we wanted to do in terms of textile centers. All right, so going back to the chunk rendering now, what this implies, right, is that we need essentially an apron. When we do fill ground chunk, we need an apron of pixels around the thing to make sure that it's always got whatever the neighboring pixel is. And so really all that is when we set up this orthographic render, right, we just need to make sure that our size is actually 2 pixels less in terms, or I should say 2 pixels more than it would actually otherwise be, right? Because we're going to render into this, but we need to capture essentially a different area into that. So this is what we are, you know, ostensibly capturing, right? But what we actually want to do in terms of this is how much we want to capture, but we want an extra apron around it, right? So what we really want to do is say, well, not quite. We actually want the width here, right, to be as if you added 2 pixels to it, right? And knowing how much 2 pixels is in terms of meters, again, we would have to know what the pixels to meters is here, which happens to be what we're actually computing, if that makes sense. Because right here we've got our meters to pixels, right? Our original value is this. So this is like original meters to pixels. And so what we would want to do let me actually draw out the map. A lot of finicky math today. All right. So we've got a thing here that we're drawing in, right? And it's 256 by 256. But what we want to do is make sure that the actual region that occupies in world space. So you know this region maps to some area of the ground, right? That's going to be drawn at 254 by 254, right? So what we need to do is make sure that actually this 254 by 254 region, right? 254 by 254. The 254 by 254 region is what actually has to map to the 254 by 254 region actually needs to be the full size in meters, right? So when we do our meters to pixels, I guess all we really have to do is say, oh, pretend that you had 2 less pixels here, right? And figure out whatever that, you know, take whatever you thought you were going to cover and cover 2 pixels less than that, right? And I think that will give us that apron around the edge, right? So I got to actually rerun it to see what that'll actually do, since ground chunks don't get redone. Of course, now I don't remember where the seam was. Let's go down to where the seam was. There it is. And hey, look, the seam is gone. What do you know? That was surprisingly easy. A lot of finicky math there where you have to kind of think it through, but then it ends up being 2. You gotta love that. We added 0.5 in one place, and we subtracted 2 in another, and suddenly all the seams are gone. Ladies and gentlemen, you know, that is something that's so satisfying when you're programming, when you're just like, okay, I thought it through, I knew what was supposed to happen, I figured out a problem, and I corrected it, and it actually worked when you did it, when you thought it through, right? Just super satisfying. So there we go. It looks like we got rid of a fair bit of the seaming. I don't know if we've got rid of all of it. It's a little hard to tell now because, again, some of that it's hard to say whether it's art or not. And that kind of looks like that's probably art, but it's really hard to say. But the hard seams that I was seeing before are now gone. And so that's at least a good thing. And like something like that right there, I can't quite tell if that's something that is a reasonable or unreasonable in terms of seaming. So I think we might still have, you know, something that maybe isn't necessarily about the sampling boundary, but that is producing some harder seams than we might want, right? Just trying to look around. So if I turn off the red-green stuff here that we were using, our kind of like ink dye, if you will. Let's go ahead and do this. There we go. Yeah. So it looks pretty much like what we would expect now. Now again, in order to make a good ground, we're going to want to do something other than completely random splatting. So we certainly aren't done with our ground generation by any stretch of the imagination. Oh, hey, look, there's a little like area that didn't get filled there. Speaking of other reasons why you don't want to use pure random. So yeah, so we've got work to do on our ground generation, but that's like more of a world generation time thing. But it's definitely looking a lot more seam-free. We've gotten rid of the systematic texture seam problem that we were having there. And so you can kind of see like that. I'm not sure if that's an art seam or not, right? Like I don't know exactly what that looks like. So that's a little bit hard to tell what exactly the art has in it and what it doesn't. So that's a little bit of an issue. But yeah. Anyway, that's looking good, and so I'm happy that we got rid of our primary rendering artifact there. So yeah, so at the moment, though, of course, we have another problem, which is that our ground chunks also aren't sorted. So we're seeing the background chunks right now instead of the front ones, which makes it pretty darn trippy to look at, right? But that's just the way it goes. So these guys, that's looking nice. I'm liking that a lot. And now we've got our pixels and texels corresponding a little bit more what I wanted them to correspond at. So and that also, by the way, what I showed there is as close as I remember it, the OpenGL pixel and texel standard. So you know, when we render it on hardware, it should look the same, pixel to pixel, unless I mess something up. But that's as I remember, the closest I remember to it. So yeah, I don't know how you're feeling about this. I don't even know what I probably should be doing right now, to be completely honest with you, because I'm wondering at this point, you know, we're zipping around here and we're generating these ground chunks so nicely. I mean, in fact, just this is so cool. Like this is getting to be a real engine, people. It's doing all sorts of fancy things here. Anyway, if I change to using a very high off the ground camera, what is happening? right. Yes. Okay. Well, that's what I should be doing now. Now we know. Right. So the thing that I need to do is everybody for their queries actually uses what this value is, like the distance, above ground for the queries for like getting the unproject and get the camera rectangle at distance and that stuff. So that was why you couldn't use that one for debugging, and you have to change. If you want to use the debug camera, you have to use in the get render entity basis. You have to do this, right? So that way it still reports the camera to the game as if it wasn't that, right? But there it goes. So that was a little bit of a stupidity on my part, but what are you gonna do? Anyway, so if we take a look at what's going on here, right? You can kind of see how cool this is already. It's just on demand generating these guys, right? And so, one thing that we could plausibly think about doing now, and I don't know if this is the best possible use of our time, right? But we only got I got 17 minutes left because we started 10 minutes late. Is we get that little kick up, right, when we go to generate those ground chunks. Now, part of that is just because we're massively overfilling on the ground chunks, really. We don't need to do 100 splats to generate a ground chunk. If we were doing a more sane generation pattern, we would need far fewer. So some of it, we could take care of that way. But since we just wrote that threading code, it sort of begs the question, should we potentially just have the chunk filling happening on another thread, right? Because now we know that we've got a thread system. We could have it just sit there and actually have some other thread that's working on filling those ground chunks. And I don't know. That's certainly something we could think about doing, and it might be fun. Because we've got that hiccup, and that hiccup is annoying, right? You don't want that in the game. And so, it's a question of how do we want to deal with it. It's pretty cool how this works. I'm really enjoying this for whatever reason. I think it's just kind of fun when you get into a nice situation where you're like generating things on demand, because then it opens up just a lot of possibilities for us down the road with whatever we really want to do in terms of how we draw the ground. We just have a lot of leeway there now, because since it's all generated on demand, we can do all sorts of things and basically create a completely unique ground texture everywhere in the world that has whatever sorts of stuff we want in it, and it can use the underlying geometry to do whatever kinds of fanciness we want it to do. So yeah, maybe it's a really stupid idea, but we could certainly look at doing that, where we fill the ground chunk on a separate thread. I have to think about how we would want to do that exactly. Because there's a couple different things. And so, maybe it's a good idea to start doing that, because we'd have to think about it in terms of queue work and how we would want it to happen. So maybe that is a useful thing for us to do. I'm not entirely certain. I guess the other thing, just thinking about that, maybe it is just good, because we're going to have to do it eventually. We're going to have to deal with this sort of thing eventually. The other thing we could do is start playing with the asset loading, I suppose. That's the other threading sort of thing we could do if we were going to go down that route. But so if we look at how this thing is working here, where we've got the tiled render group to output stuff, what we would have to start doing is partitioning our threads into stuff that's doing background work and stuff that's doing foreground work, right? And so, what we probably want to do, like we already kind of set up to this, to have a foreground thread and a background, a foreground queue and a background queue, right? We have, where is it? Where is our queue? Here we go. So we have our queues here, and we have our high priority queue. We could have a low priority queue, right? And we could just say that, there's stuff that goes on the low priority queue will kind of like happen maybe like only one thread is dedicated to servicing the low priority queue or something like this, right? I don't really know. But let's just say, like I said, I don't know. I don't even know why I'm doing this right now. I just felt like maybe we should. So we'll just say like low queue, and maybe this needs to be high priority queue, right? Low priority queue. So here we go. We should probably get rid of this at some point. I don't even know why that's there, right? So here we go. We've got high priority queue, and we've got low priority queue. When we go through and we create these things here, I guess I probably want this to be compression-oriented programming, like I always say. I basically just want something that's going to create one of these queues. So there's the platform work queue, and I'm going to create it, right? And so make queue or something. Maybe I'll just pass it in. Say, win32 make queue, right? And all that's going to do is just this, right? It's just going to do this stuff that we were doing for the queue. And it'll take with it what the thread count should be for that queue. And I'm trying to decide whether I want this to be able to steal threads or not. Well, we'll leave that for later. So anyway, for right now, we'll leave them completely segregated, and we'll see whether we want to do it in a little bit of a fancier fashion. So primarily the thing that I'm concerned about, the reason that I'm segregating these, because what we could do is we could make it, the other way we could do it is make it so that basically there's a set of threads waiting, and those threads all just pull off of the high priority queue if something's there, or the low priority queue if something's not on the high priority queue. The problem with that is that if we have things that take a long time on the low priority queue, they will starve out the high priority queue potentially and ruin our performance. So I am going to keep them segregated for a little bit. And, if we decide that we want to change that, we always can change that. It's not a big deal. The platform code the game code doesn't really know what we're doing down in here, so we can feel free to tweak it as we see fit, right, as things go. So here's the thread count is going to come from here now, and we'll put this in here like so. We'll have the thread info. What does thread info even do? Oh, thread info is just the thing that we pass, and what is in the thread info? Nothing, except a logical thread index and a queue. So I'm going to change that, since the logical thread index isn't even used at this point. I'm just going to go ahead and say that this platform work queue, that is what actually gets passed here. So here's the queue. Because we don't actually need any of this anymore, at least not for the moment. So that goes away entirely. Goodbye. And then we don't care about this at all. So now we have the thread count. We don't care about this. That's not relevant at all. We don't care about any of this. And all we do here is instead of info, we just pass the queue pointer. And what else does a queue have in it that might need to be initialized? I think nothing. They all initialize to 0, right? Yeah. So they're all clear to 0, so that's all fine and dandy. So we make 2 queues here. And then what we need to do is we need to actually initialize them, right? High priority queue, low priority queue. And we don't actually really need to clear those to 0, do we? Because we don't actually do we actually ever care? No, we don't. So actually, we could actually just do this a little bit differently. We could do it this way, where instead we just say, oh yeah, the queue gets initialized here, like so. To all zeros, but not that giant entry list of things. because that way we don't just spend a bunch of time clearing for no reason. So we can initialize those. We make the threads. We kick off the threads, and now we've got a queue, right? And so that should be fine. Let's go ahead and compile that. This has got to be an arrow. And that's got to take an address. So then what we could say is like, oh yeah, okay, so, you know, instead the high priority queue is going to be 6 threads and the low priority queue is going to be 2 threads or something like that, right? And then when we run it, off we go. Seems fine, right? And everyone's happy. And so now we've got another queue that can have some stuff in it, so work can be done. And let's just go ahead and make that happen. So if we go in here now to handmade.cpp, and I take a look at fill ground chunk, right? When we do tiled render group to output, what we want to do is now, instead of passing the render queue, we want to do like the low priority queue, right? So the trans state, when that takes the render queue, it's going to take the low priority queue as well. Low priority queue, low priority queue. Probably should just call that the high priority queue. I don't know why I called it the render queue. Doesn't even make any sense really. It's not like you couldn't use it for something else. High priority queue, low priority queue. Yeah. So with that, I think, is really all we would need to do to get things started. But we will have, obviously, well, you know what, I'm just going to do it, and then I'll show you the problem that we're going to have, which is kind of, I don't know what it'll actually do. I'm kind of interested to know. But anyway, so we have a couple things we have to do here. First of all, our render targets have to be aligned. That was one of our requirements for them, right? And so one of the things that we have to do here is when we actually allocate these ground chunks, they're going to have to be aligned, right? And so when we do our initial ground chunk creation, right, in here, when we do make empty bitmap, that's got to actually give us an aligned bitmap, right? Because everything needs to be aligned to those SIMD boundaries, to those 16-byte boundaries. So in ground buffer bitmap, I have to, in fact, why is that working? I guess it just happens to be. Now that I think about it, we had to do that before. That has nothing to do with the threading. That's just because the renderer is accelerated, right? So that should have been already a problem. Let's see what is make empty bitmap doing when it allocates this stuff. It just does a push size. Yeah, it just goes ahead and does a push size, but it never actually ensures that it's aligned, right? Which is kind of ridiculous. So okay, that's a little odd. One has to admit that is a little odd, right? Are we admitting that? Does anyone else admit? I don't know if anyone's admitting that. I hope you're admitting it, but I don't know if you are. So, well, what I would like to do here is I would like this to start passing alignment. So I guess maybe, I guess we'll stick with the thread thing, but that's a pretty big to-do item. So I don't know how we want to mark off this as a to-do item. Normally I have a little pen and paper here. Maybe I will just use a pen and paper, which I have here, and start that for Handmade Hero. So let's see what we've got here. I'm going to write down our first official to-do item on the paper, which is push size, alignment, and ground chunk allocation. But it's working properly because I guess things just happen to be 16-byte aligned so far, and we just didn't hit that, which is odd. computers are complex. Sometimes things just go your way. And you luck into something that should have been broken and just isn't. But anyway. So, yeah, what I want to do now is I need to kick off rendering on these guys, right? And so if you remember the way that we could do this before, we have a way to push things on a queue, right? We just do platform add entry, like so. And that just is one of these guys. It's one of these do tiled render work things, right? And so what I'm going to do temporarily, and this is not really a long-term solution here, and it actually does also suggest there's probably one other thing we want to do to our queue, but we'll get to that later, is we've got fill ground chunk. Well, I guess it's actually just fill ground chunk. Let's see here. Fill ground chunk. Where is fill ground chunk? Fill ground chunk. There we go. So what we want to do here is we want to make the stuff that happens inside fill ground chunk. We want that to be callable from the work queue, right? And so what we need to do there, all of this stuff is pretty much rote, right? For the most part. Right, it just does a begin temporary memory for, I guess, for the render buffer. Yeah. Then it just does arena allocation. And the arena allocation is just for that render group, right? Yeah. So I think really the primary thing that we would need to do here is we just need to have a way of kicking this off. So that, I guess I won't try to do that. We're not going to fit that all into 2 minutes. I mean, maybe I could, but I wouldn't be able to talk at all during the entire time. Because that actually gets into also extending our temporary memory stuff to be a little bit more flexible. But yeah, that's mostly what we'd have to do in order to do the tiled render work, is we'd have to put that in here. So I'll go ahead and just comment this out, and maybe we'll do that. We'll do that soon. Why did I paste that? That was not what I wanted to do. There we go. Ooh, what just happened? Wait a minute. Oh, right, because that's calling the low priority queue. That I did not actually mean to do. Let's put that back on there. Wait a minute. How is this possible? You're telling me just because I happen to mention that the thing is now is not aligned, it's actually complaining about the alignment just now. That can't be true. Like I only just said, oh wait, this isn't aligned. Why was that working before? And now it actually is not working. How is that even, how does that happen? I mean, seriously, people. And you know what's probably hilarious about that? Let me see if I'm actually right. Man, that is hysterical. Okay, this has been a great Handmade hero. So did you guys catch what happens there? So, like I said, we shouldn't have been able to render the ground chunks with our renderer because it should have been unaligned. But it just so happened that it was on a 16-byte boundary anyway. As I was saying that, I happened to be adding the low priority queue. The low priority queue is on the transient state structure, which happens to be in the same place, right? That's in the memory arena, the transient arena. That happens to be where we are allocating our ground chunks from. So by adding another 8-byte pointer, that pushed it out of alignment to 16, right? So we could just add, if we wanted to, right? We could add one more 8-byte pad to the structure, and that would force all our ground chunks into alignment. So I guess now that I think about it, it's not that odd, because since all of our stuff is really going to be aligned to 8 bytes probably, since we're compiling in 64-bit mode, we had a 50-50 chance that our ground chunks would be aligned, right? Oh, that's great. That's definitely where I'm ending it and going to the Q&A, because that is hilarious. I love that. That's so great. Let's go to the Q and the A. If you have questions, please put Q colon in front of them so I will see them. How are we doing out there? What's going on? Orlando Boom, good stream today. Sometimes it goes really great. Yeah, sometimes you luck out, and sometimes you don't, right? And that's programming. And the stream captures that, right? The stream captures days when you hit something neat and it's cool. And the stream also captions days when you're just staring at something going, what is going on here? So... the ground chunks render differently every time you go upstairs and come back down. No, they don't. It's the same. They're based on their coordinates in the world, so they're always exactly the same when you come back to a region. That's obviously what we want, because we want it to look familiar, right? Because, I mean, we're just splatting things in there willy-nilly right now, but what we're going to do eventually is be thoughtful about how we compose that ground texture so that it looks meaningful to the player, like whatever the region is that we're on. Abner Coimbray, can you address the recurring question, the stream isn't about making games. I'm tired of trying to explain what the stream is about. So this stream is about making games. It's about making games from scratch. There are lots of streams that are about how to load up Unity and like drop some entities in, but you know, I mean, that's really not all that difficult. And so what this stream is supposed to do is to teach like how Unity was built, right? Because obviously people need to be able to make game engines, otherwise we wouldn't have any game engines like Unreal Engine or the Unity engine or the Crysis engine or the Source engine or countless of the custom engines that are out there for, you know, specific games. I don't know, like whatever Grand Theft Auto 5 uses, the Frostbite engine. So this stream is about the whole process, and we will do the kinds of stuff later on where, you know, once we're done with engine work, we'll do work on, you know, game stuff that looks a lot more like just working on you know, what you might see if you were using a store-bought engine. But saying that making an actual game from scratch isn't about making games is really strange, because if there weren't people who knew how to do all the things that I'm talking about on the stream here, nobody would be able to make any games, right? I mean, all of this stuff is actually required to make a game, and the only reason that you don't have to know it all is because you can go license something that might do some of it for you. But of course, if you do that, you also put yourself at a pretty significant disadvantage, because everyone else has the exact same tool you do, right? So you're never going to be able to do anything technologically to differentiate yourself from another game that also uses Unity or that also uses Unreal Engine 4, because guess what? That's all you got. So it's important to know these things, I think, in general. If you care a lot about game development, I think you should know these things because they're important, right? And they have a lot to bear on. They have a lot to do with the future of game development, right? They have a lot to do with who will make the engines of the future, who will make technological advances. Nobody who doesn't know the stuff that I'm teaching on Handmade Hero is ever going to make a significant engine advancement, right? Because anyone who can do something beyond what we're currently doing with things like Unity and Unreal, they all are going to know all this stuff, right? This is like, Handmade Hero is like the compulsories for an engine developer. You should be able to do absolutely everything in here if you're going to be on an engine team, right? And I don't think that's any kind of extraordinary statement. Like, I feel like any good engine programmer I know, if I was like, would you feel comfortable making Handmade Hero from scratch? They would be like, certainly, right? Of course. And so I feel like, are they going to do it exactly the same way I do? No, because every programmer has a different style, right? But they would be able to achieve the results. How long have you worked on this project? 130 hours ish, something like that. So that's 40. So 3 weeks of programming time. If we were working for 40-hour weeks, it would be 3 weeks. So we're 3 work weeks into the project, roughly, a little more than that. How are you deciding what gets queued or not on high versus low? So the idea is that anything that needs to be computed this frame is a high priority item, and anything that could be computed sort of across a couple frames is going to be low. How are you going to implement seamless tiles with what Yangshin Lee creates? So that is what we're doing here. We are taking artwork that she made and we're splatting it in to create seamless tiles. She made the splats. Now, we haven't actually done the work to create useful things out of the splats. We're just randomly throwing them on there, so that's not particularly useful. But when I'm saving how we would do more logical creation of stuff underneath with the splats until we get to world creation. I don't see any object-oriented patterns. Are you using object orientation? No, we are not. I assume the yellow, cyan, magenta squares are for debugging. What do they represent? Yes, so we're in the camera zoomed out mode here, right? And so if we change to actually viewing the game, right? This is what it would actually look like. And you can kind of see that the yellow square is right around the border, if that makes sense. And so what the squares are for is when we want to do some debugging work and we take a look out here, this yellow square represents what the player will see on the screen. This cyan square represents the simulation boundaries. So we're simulating everything in this region so that things that are off screen can still like walk on screen and stuff. And the purple boundary is the region where we consider things, so that stuff in this region as it moves outside might hit something in here, but these are not actively simulated, if that makes sense. So yeah, so that's basically what we're trying to do with those regions. And they'll come into play more later when we're actually working on the game part of the game and not the engine, because, again, when there's stuff like AIs that have to walk around or whatever, it's important to make sure that we can see that they're properly being simulated out here when they're not on screen. You always say we. Who is we? Well, it's me and everyone on the chat. Looking for some on-topic questions. You say 3 work weeks, but do you feel like you could maintain this pace 8 hours a day? Well, okay. Obviously, yes, because when I'm normally programming, I don't have to explain it all when I'm doing it. So, like, yeah, maybe it would be hard to program for 8 hours straight every day, but the amount of programming I do on the stream would not take me an hour. It would take me like 15 minutes, right? A lot of the time. Sometimes, if I have to think something, if there's something I have to think through, then maybe that takes the same amount of time because I'm going to draw it, like explaining it on the blackboard is the same as me working it on a piece of paper. So that part math's probably okay, but the vast majority of things that I explain are things I already know and can just type in. And so those I take a massive hit on the stream. So I think it's totally fair to say that it maps basically to work hours because normally I'm way faster at coding than what you see on the stream because on the stream I have to explain it. And I can't concentrate on that because I have to talk too. So I'm also at a disadvantage in terms of remembering where everything is. And I work full time to the day normally, so I'm also have to page in this code since it's not the code that I normally work on. So yeah, I think it's very fair to say. It seems like the ground chunks are only getting generated when they would actually be visible, not before. When you get the ground chunk into low priority queue, will empty ground be visible for 1 or 2 frames while they're being generated? Yeah, so what we will want to do once we have them generated is we'll want to sort of see what our typical event horizon is for generating ground chunks, and we'll want to queue them up a little early, which is pretty easy, right? We just use a slightly bigger region. Do you think at the near end, someone like John Blow would be interested in making a game with the Handmade Hero engine in a similar format to see how the game design phase evolves the engine? I don't know. You'd have to ask him. All right, I think that's it for on-topic questions. Am I correct about that? I think. Anyone? Anyone? No, looks okay. All right, well, we will go ahead and wrap things up then. Let's go ahead and save everything out here. There we go. Close. All right. Thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the code at home, you can always go to handmadehero.org and pre-order the game, and it comes with the source code. So you can download it every night. After I'm done here, I upload it, and then you can download it, and it's all good. So if you want to play around with it at home, that's an easy way to do it. You can also go to our forums page if you have questions, and you can ask questions on the forum. You can also go to, there's like an annotated episode guide, and there is a ports page and a resources page. There's all kinds of stuff on there that you might want to check out. We also have a Patreon page if you want to support the video series. It's always much appreciated. And we have a tweet bot that tweets the schedule at you if you're trying to catch the series live. You can subscribe to the Twitter feed and it'll tell you whenever it's going live. So that's about it. We are off tomorrow, as I will not be here tomorrow evening. So we're off tomorrow, but we will be back here on Monday. So I hope to see you all then, when we'll go ahead and start playing with that low priority queue and see if we can't get our ground chunks to move off of the main thread so we won't have those hiccups, which would be good. All right. Thanks, everyone, and I will see you tomorrow. Oh, no, I won't. I will see you Monday. All right, take it easy, everyone, and have a good weekend, I suppose. Well, since I'm not going to see you tomorrow, have a good weekend, and I'll see you on Monday.